Good morning. On behalf of the waterfalls behind me and myself, we'd like to introduce you to episode 2, The Big Bang Part 1. In this particular episode, I'm going to be diving into the Big Bang theory and all of the strangeness that comes along with that theory. So buckle up and let's get this party started here. So the theory itself is nothing new. It's been around since 1927. And the fact is that it's had a lot of staying power, considering it's almost 100 years old. The foundational aspects of the theory still are valid to this day. And the foundation of the theory is basically we started from a small area and expanded outwards from that. Now, there's certainly competing theories with this. And there's complementary theories that have advanced the original theory to where it originally was. An example of that one is, or example of one like that is the cyclic model. And this one is stating that we've not had one universe and one Big Bang. We've had multiple universes and multiple Big Bangs. It's sort of like this heartbeat model or bounce model where a universe expands and then it contracts, and then another Big Bang, and it expands and contracts in this never-ending cycle of universes and Big Bangs that occur. So that particular model, that came about due to the fact that in looking in the outer reaches of the universe, scientists have discovered these galaxies that seem to be cold zones. On top of that, their age appears to be older than the universe, our universe itself. So it does beg the question, how did something older than our universe get into our universe? And the logical conclusion is, well, it's a fossil. It's been left over from a prior universe. So that is one theory. Again, there's a lot out there, but it just goes to show you that as time evolves, so do the theories along with that. So having established that, let's step back and put yourself in where we were when the Big Bang, right before the Big Bang occurred. And let me read a statement, a description of what it looked like back then. So 13.8 billion years ago, the universe was a point of infinite density and temperature, containing all matter, energy, space, and time. So there's two words in that, infinite and all, sort of speak volumes. Basically, everything that we know about the universe was stored into nothing. So that is a relatively hard concept to understand. It makes no sense at all. And I'm going to get into a little bit of that later on in this episode. But for argument's sake, just work with me here and let's go along with that, assuming that is the case. Now, that particular state is referred to as the singularity. Basically, everything in the universe in an area of nothing, essentially. The term, when you hear the term inflation, is a term that describes when we went from that singularity state and we started to expand, and we are basically still in inflation. Not economically, we are that too, but in terms of the universe. Now, relative to the expansion or the inflation, the one thing that you need to realize is everything that is moving in the universe is not moving on its own. In other words, our Earth doesn't have a jetpack on it and we're zipping along. What's happening is the space is stretching outward. And as a result of that, we're part of that space, and it's bringing us along for the ride. So the analogy is like raisins in dough. When you're proving that dough, it's expanding. And when the dough expands, the raisins expand. And hence, there's the analogy of how objects in the universe, in the space, are playing out. Now, as you're going to find out in a future episode, space is not this passive thing just hanging out there. It's a very active and a really strong influencer of the behavior of the universe. So keep that in mind as we talk about this later on. Now, having said that, I assume probably about 20 questions have popped into your head. Now, I came up with 3 that you may have thought of, so I thought I'd address those because they certainly top of mind with me. So the first question is, how do you know that the universe is 13.8 billion years old? Where would that come from? Secondly, what caused the Big Bang to occur in the first place? And then third, what is this singularity thing that you're talking about? I can't even begin to understand how everything could be stored in nothing. So we'll get to that. So let's start with the age first. Now, the 13.8 billion figure just wasn't pulled out of thin air. What scientists have done, and by the way, when I use the word scientist, I'm referring to astronomers and physicists and engineers and mathematicians, and the list goes on and on. So it's just sort of a roll-up of all of those professions. They're looking into space and observing a number of things, and there's three in particular data points that they're looking at and capturing that are feeding into determining the age of the universe. One of them is called redshift. The other one is called cosmic microwave background, CMB. And the third is elemental ratios. So let me just go over those briefly. Redshift, that's the detection of light and how light is being stretched and how light is shifting. And based on that shift and stretching, they can determine how old an object is in space. So that's number one. Number two, relative to the cosmic microwave background, that is measuring radiation, similar to the redshift with light. Same thing. Variations, you can tell what the age of something. And then in terms of the ratios, that ratio would be between hydrogen and helium. And you're certainly going to learn a lot more about hydrogen and helium when I talk about the sun in another episode. So if you look at those three reference points and you do a little triangulation, you come up with the 13.8 billion figure. It seems to be pretty accurate. And so that's not a theory, that is a direct observation that has been made, and that figure has been around for quite a while also. So that seems to be pretty true, all right? Now, in terms of what caused the Big Bang, let me tell you a little secret. I don't want anyone to hear it. No one knows. I mean, the bottom line is there's all types of theories out there as to what caused the Big Bang to occur in the first place. But then it brings up all these other questions as to this singularity of everything stored into nothing. How did that form in the first place? And then what happened before that? So there's this never-ending series of questions without a lot of answers. What I can tell you is, if you come up with your own theory that gets the attention of the Nobel Committee and it's proven correct, I assume your bank account will certainly be a lot bulkier due to the fact that you might win the physics award for that particular theory or discovery. So just keep that in mind, that a lot of questions that people have about the universe, they can't really be answered because there's no facts really to back them up. So hence again, that's what theories are for. Now, the singularity weirdness. Let's go through a little thought experiment here to maybe give you a perspective of what singularity is about. So here we are, we're expanding every minute, second of every day, we're expanding outwards. Now let's assume that we quit expanding one day and we started to contract. And we contract, a week from now, we're a little bit closer, everything's closer together. And then, it keeps on going backwards and backwards until you get to 13.8 billion years from now. What is the universe going to look like? In other words, we have planets and stars and comets and dust and you name it, all coming together into one point. And the logical conclusion is, well, maybe it's going to merge and create a singularity. I mean, that's certainly a theory, that's a possibility. Or maybe what's happening, or what's going to happen, and this reminds me of the Predator movie, as a matter of fact. And by the way, Predator 1 is the only really Predator movie, but that's a different story. If you remember the Predator, that ugly Predator, if there are scenes in that movie where he comes into physical form and then he sort of goes into this transparent, wavy form that he sort of is integrated in with nature. He becomes sort of like this force field. And if you think of the universe that way, if it came to that point where everything's back together again, is it possible that everything that we think is that you can touch and feel can turn into a different form at that point in time, and it can merge into a singularity? Now, as you're going to find out in later episodes, there are some strange things with this universe that are facts. And this is another example. Could this be a fact? Who knows? But it's certainly something to consider, because you got to keep an open mind with this universe, because if you don't, you'll lose your mind. So one last thing about singularity. So anyway, that sort of lays the foundation of how that could possibly be. I'm not sure it answers the question directly, accurately, but incredibly for that matter, but it's certainly one scenario. Now, when you hear the word singularity, a lot of people think of, basically it equates to math, not necessarily physics, but essentially singularity equates to infinity. In other words, if you can store everything into nothing with the singularity, the cosmic singularity, that's an infinite state. If you divide any number by 0, that's an infinite state. Artificial intelligence, because artificial intelligence just keeps on getting smarter and smarter, and there's basically, it feels like infinity, that you can't stop it from getting smart, then that is an infinity, which certainly freaks people out, because that's just very uncomfortable, thinking that something could be to get to that point anyhow. So I thought I'd set that foundation down, because a lot of people think that singularity only relates to the cosmic world, and it doesn't. It's much broader than that. So let me complicate our lives even more by talking about black holes. Now, when you hear the word singularity, there's a good chance that the singularity exists within a black hole. Now, to complicate matters even more, you can have a singularity called a naked singularity that is not in a black hole. But let's assume the singularity is in a black hole. Now, for those unfamiliar with the concept, or black holes, that concept, it's a region in space-time. Now, I use the word space-time, not space/time, space-time. And once again, another episode on space-time, which is basically probably my top 3 weirdo things about our universe, that it's really hard to get your head around this one, but we'll get to that down the road. So it's a region in space-time where gravity is so strong that nothing, not even light, can escape it. In other words, you have all this immense gravity because it's sucked in, it's hoovered in things in the universe. And as it sucks in more and more, the gravity gets stronger and stronger. Well, as a part of that black hole, guess what could be at the center of that black hole? A singularity, because it's turning basically everything into nothing, or storing it at that point in time. Now, to throw another wrench into the works here, and I find this one sort of funny because of the name itself. There is a competing theory out there, of course there is, because there's competing theories for everything, that instead of the black hole singularity paradigm duo, you have something called a fuzzball. And a fuzzball, it deals with string theory, and which I won't even get into, and again, that's another episode. I keep on deferring all these other episodes, but it gets so complicated that you got to sort of break it up into bits and pieces, because it drives you nuts. But the bottom line is, there's the competing theory being a fuzzball that's behaving like a black hole singularity, that paradigm, but the foundational aspects are different from it. So we'll leave it at that for now. So what I'm telling you is, if you're in a discussion with someone and they ask you what your family tree looks like or where you're from, you can say that without really lying that you may have come from a fuzzball, which would be a good conversation starter at a minimum. So with that said, let me summarize what we learned in this episode. That one, we were formed from this bang event and we're expanding outwards. We don't know how far we're going to expand. We don't know what's going to happen when we hit the limit of that expansion, if there is a limit. We don't know if we're going to contract. We don't know if we are going to collide one day down the road, billions of years down the road, when everything does come back together again, assuming that's even the case. So essentially, there's a lot that we don't know, and we won't know for a long, long time. So with that said, the next episode is going to take us to the next phase of the Big Bang. In other words, this particular episode is dealing with sort of what happened at that point. The next episode 3 is going to focus in on what was formed after the Big Bang, which really is creating the environment in which we live in to this day. So with that said, I will see you on episode 3.